Washington State University. Go Cougs!
Hello everyone. In this video, we're going to cover Lesson 7 of the Working with Activity and Health Data module. We're going to discuss time series and see an example of working with real-world time series activity data. So let's get started discussing what is time series. A time series is a series of data points that are indexed in sequential time order. Most commonly, a time series is a sequence taken at successive equally spaced points in time. And the spacing between these time points can be any value. For example, anywhere from 1 to 60 seconds, or 1 to 60 minutes, or maybe 1 hour, 12-hour, or 24-hour cycles, 1 day, 7 days to form a week, 1 day, 52 weeks to form a year, or 1 or more years. Really, the spacing is dependent on the domain, the application, and you can even choose the spacing if you want to resample your data. So we're going to work through an example where we're going to work with the SH1 hourly activities.cv dataset. So let's take a look at this dataset. Kind of hard to see here on GitHub, but we have several columns called date, hour, bathe, bed, toilet, transition, cook, eat, enter home, leave home, personal hygiene, relax, sleep, take medication, wash dishes, work, and other activity. So except for the first two columns, the remaining columns represent activities, and values in these columns are probabilities that those activities are occurring at a certain date and a certain hour. So for example, on July 18th, 2013, at midnight, there's a very low probability of performing any of these activities. These are all special values to prevent division by 0. So what we're going to do with this time series data is we're going to load it up into a data frame. And we're going to see two different ways to load it into a data frame depending on how we want to represent our index. So our index is the tuple date and hour. So since this is hourly data, you can see that for one date, such as July 18th, 2013, we have midnight, 1 a.m., 2 a.m., so on and so forth, all the way until we reach 23, which is 11 p.m. So for every day, we have 24 hours of activity probability data. So this is an example of a real-world activity time series data set. So let's get started writing some code. Initially, we may consider reading this data into a pandas data frame with a hierarchical index, where our outer index is a date and our inner index is an hour. As I said earlier, a date and an hour uniquely identify the activity distribution for that time of the day and that day. So let's try writing some code to read this in using a multi-index. So here's my file name. Let's go ahead and let's call it hirdf to represent that this is a hierarchical data frame. pd.read CSV, go ahead and read in fname, set header to be the first row, and we'll set index column to be the first two columns for our multi-index. And we're going to print out the data type of our index because later we're going to look at a different type of index and we're going to see how they're different. So this is the first time we're working with this new data set. Let's also print out some more information about the data set. Let's do the shape, the number of days in the data frame, which we're going to be able to compute by the number of rows, integer divided by 24, since there are 24 hours in a day. And let's just take a look at the first 5 rows of our data frame. Okay, that should give us a good sense of this data. Okay, so we see the data type of our index is a multi-index. It's 168 by 13. So there are 13 columns and there are 168 rows. 168 integer divided by 24 gives us 7. So there's 1 week worth of activity data for this particular smart home resident. So we could use a hierarchical index for this data. However, since it's time series data, it makes more sense to use the Pandas date time index, which is specifically designed and implemented for working with time series data. While there are many benefits to using a date time index for time series, I've listed here a few of my favorites that we're going to see in this course. So first off, easy resampling with the resample method. We're going to see an example of this here shortly. Quick access to date fields via properties such as year, month, etc. So if we ever need to quickly figure out what is the year of this data, we can use just .year and find out that value. Union of overlapping date time index objects with the same frequency is very fast. So this will be good for combining data frames for aligning on an index, and partial string indexing. So we don't have to type the entire hour, minute, second, year, month, day in order to, say, get certain hours or certain days. So let's take a look at reading in this data again, but this time we're going to use a date time index. And I'll show you how to do it. So data frame is going to be assigned pd.readcsv, fname, header gets 0. Everything so far is the same. But this time, instead of specifying the index column, I'm going to specify the keyword parse dates to be a dictionary where I'm going to create a new field in my data frame called datetime, and it's going to be constructed from columns 0 and 1. So I'm not specifying the index to be columns 0 and 1. Instead, I'm just going to make a new column in my data frame called datetime that's going to parse the dates in columns 0 and 1 to construct a datetime index. So now I'm going to set the index of my data frame to be datetime, and let's do this in place. And then let's go ahead and just copy this code down here so we get similar output. But we're not going to use higher df, instead we're just going to use normal df. Okay, so our output for our type is now a date time index, whereas before it was a multi-index. So we have a different object for our index, or a different class. Then we're printing out 168 by 13, which is the same we had up here, and the same number of days. So that seems to be aligned well. Now we print out the first 5 rows of our data frame, and we don't see a hierarchical index. Instead, we see what looks like a standard index called datetime, but this here is really a string representation of a timestamp object. We won't talk about timestamp objects, but we are going to work with them for resampling and indexing into this data. So let's take a look now at this first bullet point I have here for why it's really great to use a datetime index over a standard index or a multi-index when working with time series data, because of the resample function. So suppose we want to resample our time series data. By resample, I mean change the frequency or the period at which our data is stored. So in our current example, we have hourly data, but say instead of hourly data, we wanted, say, data in terms of every 6 hours. Or maybe we had minute by minute and we wanted to aggregate that data to be hourly. So just resampling is just going to change the period or the frequency of our data set. So in Pandas, we'll use the resample method to do this. And Resample expects to have a string representing the integer frequency and the character of the unit to convert to. So for example, if we wanted to convert our hourly data frame to 2 hours, then we would pass the string argument 2h into Resample. If in another example we wanted to aggregate our data to 5 minutes, we would do 5t, 30 seconds, 30s, 1 day, 1d, 4w, 4 weeks. And there are a lot more than those listed here. Those I just think are some of the more common ones. So let's go ahead and try it out. Let's resample our activity data to daily averages. And I'm going to put stars around averages to emphasize that it doesn't have to be an average. We could compute a sum, for example. So let's set our activity that we're interested in to work. We don't have to specify an activity, but just to keep our output small, let's just look at the work activity. So our data frame resampled to daily is going to be df.resample, passing in 1d for daily. And I'm going to say .mean in order to denote that we should resample by taking the average for each hour for 1 day. And then we'll print out daily df. Okay, so it's quite long here. So let's go ahead and just take a look at our activity, which we've set to be work. So here is work average for 24 hours for each day. So it looks like, for example, there is a pretty high probability on July 23rd, 2013 that this particular resident was doing some form of work, but much lower probability on some of these other days that they were performing work. And we can quickly investigate other activities as well, say cook, and we see the probabilities averaged over 24 hours for the cook activity.